In this video, we're going to be deriving the formula for the present value of an ordinary annuity. So in the last video, we presented the concept of present value of an annuity. In this video, I'm going to give you the formula, which I've written right here, and then also explain where that formula comes from. Okay, we'll be deriving this formula. Okay, so it says the present value P of an annuity of N payments of R dollars, each at the end of consecutive interest periods, with interest compounded at a rate of interest I per period, is given by this formula. Okay, now I could just give you this formula and you could do all the problems based on this formula, but it's nice to know where the formulas come from. Okay, so let me remind you our example from the previous video. We had an ordinary annuity where we were putting in $500 per year at the end of the year for 10 years at 7% interest. Okay, compounded annually. And the question was, what was the future value and what is the present value of this annuity? So by future value, we mean how much do you have in this account at the end of 10 years? Okay, now why at the end of 10 years? Why am I choosing as the future value? Well, that's how long the annuity is. Okay, well notice we plugged it in the formula. We got $6,908.22. That's the future value. And notice it should be more than $5,000, right? Because if we put $500 in each year for 10 years, we put in a total of $5,000. So our future value, since we're gaining interest, it should be more than $5,000. Right? Okay, now notice we did not put the $5,000 in one big lump sum at the very beginning. We spaced it out. Okay, we made 10 payments of $500. Okay, the question is though, if we wanted to have this future value of $6,908.22 without having done this annuity, if we wanted to just figure out how much would we need to put into an account right now at the very beginning of the 10 years, in order that 10 years later you end up with this amount, how much would you have to put in? It turns out that you'd have to put in this much. Okay, $3,511.79. That's the present value of the annuity. Okay, if you put in $3,511.79 just as one lump sum payment and you got 7% interest compounded annually, at the end of 10 years you would have this $6,908.22. Okay, so how do we find those? Well, to find the future value, we use the formula for the future value of an ordinary annuity. Okay, and we did that in the previous section. But the present value, how did we find that? Well, once we found the future value, we used the compound interest formula to find the present value. So to find the present value, we really did a two-step process. We used these two formulas. Okay, but I'd like to combine these two formulas together and just do it in one step, have one formula. And it turns out when you combine this formula and this formula, these two formulas, you're going to get the formula we had at the beginning of the video. Okay, the formula for the present value of an ordinary annuity. Okay, so how do we get this? Well, let me explain the process. And by the way, the next 2 or 3 minutes of this video, the rest of this video, you can kind of skip if you don't want to see all the messy, gory details. But it's an algebraic computation. Okay, so notice that the S represents the future value, and also the A represents the future value when we're talking about the compound interest formula. We're not dealing with annuities. So the S and A are really the same thing. So what we can do is we can set this P times 1 plus I to the N equal to, right, this right-hand side, equal to this right-hand side over here, since they're both equal to really the same thing. They're both equal to the future value. So we can write it as equals R times the quantity 1 plus I to the N minus 1 all over I. Okay, now we want to solve this for P. Okay, remember R is the payments and P is the present value. We want to know what P is. So how can we do that? Well, we can divide by 1 plus I to the N. Right? Notice that will cancel here. Well, we also have to divide this side by 1 plus I to the N, but another way of saying divide by 1 plus I to the N is multiply by 1 over 1 plus I to the N. Okay, so it's kind of like we've divided by 1 plus I to the N on both sides of this equation. On the left-hand side, we have P. On the right-hand side, we have R times this quantity times this. Now, when you multiply two fractions, you could just multiply across the top do this times this, and multiply across the bottom. That would be perfectly acceptable. But another way to do it is we could take each term in the top of this fraction and divide it by 1 plus I to the n. So in other words, kind of a simpler example. If you had a over b times c over d, that's the same thing as ac over bd. Right? That's just how you multiply fractions. But actually, another way to do it, an equivalent way, would be to say a times c over d all over b. So in other words, the a over b, we still have that there. We can put the c over d, really the whole thing on the top of the fraction. That would be the same thing. By the way, this expression and this expression really are equivalent. So that's what we're going to do over here. We're going to take each of these two terms and multiply by 1 over 1 plus I to the n. We're really dividing by this term. So what we have is still the I in the denominator. In the numerator, we have 1 plus I to the n times 1 over 1 plus I to the n. We just get 1. Okay, and then minus what we have is 1 over 1 plus I to the n. Okay, 1 times this. Okay, and finally, we can rewrite 1 over 1 plus I to the n. That's the same thing as 1 plus I to the negative n formula. Okay, all over I. Okay, and so this formula right here is the formula for the present value of an ordinary annuity. And notice that's the same formula that I gave you at the beginning of the video. Okay, so that's how we derive this formula. Now in the next couple of videos we'll see some examples of how this is used.